Okay, testing. Okay, I think audio works. So it's been a while. It was the holidays, hanging out with family, but we're back on the grind, and we're gonna stay consistent. So let's go to the next lesson, which is reciprocals. So 1.6. Reciprocals. Okay, so we learned on page 8 that adding 0 to a number doesn't change the number, and they give this example. Yep, that makes sense. Anything added with 0 will just give us this value back. For any x, for this reason we call 0 the identity. So this is called the identity for addition. So 0 is the identity for addition. In section 1.4, we also learned that for any number x, there's a number called the negation of x. So we learned that the negation of x is just negative, or negation x, whose sum with x is this identity. So they're saying that if we take the negation of x, we get 0. We'll see what they're trying to say. So we also learned that for any number x, there's a number called the negation of x, whose sum with x is this identity, 0. That is, negation x is the number. Negation x is a number that goes in the blank in the equation. Okay. Does multiplication have an identity? It isn't 0 since multiplying. 1, yeah, okay. Anything times 1 will just give us x. Anything added with 0 will give x. So 1 is our identity for multiplication. But the question we really want to ask is, given any number x, what number can we put in a blank to solve this equation? X equals 1. Okay, to answer this question, it's called a reciprocal of x. For any number x, a reciprocal of x written as 1 over x is a number such that 1 over x times x equals 1. The number is also called the multiplicative inverse of x, and we can say that 1 over x is as 1 over x. Okay. Of course, you've seen this sort of number before. Yeah, it looks like a fraction. So reciprocals are similar to fractions, I believe. Like, reciprocal of 2 is 1/2. Same with 1 or 3, 1/3. 1, 1, just 1. So they're saying to treat reciprocals not as a fraction, but as a new kind of number. We should think of it as reciprocal times x that gives us 1. It gives us 1. We're going to assume that every number except for 0 has a reciprocal. However, the number 0 cannot have a reciprocal. We will see why in our first problem. Okay, so let's start working on these problems. So problem 29A. What is the product of 0 and any number? That's easy, 0, because we know that any times or any number times 0 will just give us 0. So if we take, I don't know, do they want us to somehow prove it or say this? I think they just want us to know what is the product of 0 and any number. It's just 0. Using part A, explain why 0 doesn't have a reciprocal. Hold on, let's go back to problem A again. So I understand what's going on. Using part to explain why. You can't have 0 in the denominator. Undefined. Okay. So problem 30, explain why the reciprocal of 1 is 1. I have to look back at that definition. Okay, so if we take the reciprocal of, well, we know that this right here just gives us 1, which is equal to that. So in other words, one over 1 is really just 1. What is the product of 1/2 times 2? Well, that's just 1. Okay. B. Using part A, explain why the reciprocal of 1/2 is 2. Wait. What? Oh, okay. Explain why the reciprocal of 1/2 is 2. Are they asking for What are they asking for? Explain why the reciprocal of 1/2 is 2. Okay, what if I did this? I'm not too sure what they're asking for. Using part A. Okay, let's think about part A again. What is the product of 1/2 times 2? Okay, I know the answer is 1. But what are they trying to say? Product. I have to look back. I know just by the definition, the multiplicative inverse, this would just be 1. I don't think that gives me any insight though. And then using part A, explain why the reciprocal of 1/2 is 2. So I think they want me to do something like this. And that's really, I know we haven't learned about division yet, but this is confusing. Is that what they're... Why is it 2? What in the heck? I know how, okay. Let's say that this this? I know that we have to flip the fraction to turn into this, and then we get 2. So it's 2 because the reciprocal of 1/2 just turns into 2. What? Explain what. Well, we haven't learned division yet, so I can't do that. Okay. What if we took this number put a blank here times and says, okay, we have to get 1. How would we do that? Like, what needs to go here so that we can get 1? I think this would be 1/2 because this is really 2. But I haven't explained why. I'm not too sure. I think I need to come back to this one after I finish the rest. I'm just not sure. Like, what are they trying to ask? Okay, let's move on and then we'll go back. I just don't understand yet. What is the product of 5 times 7 and 1/5 times 1/7? So we know that in multiplication we have the commutative property, so we can move these numbers around. So we can do something like this. Now both of these products turn into 1, so we're left with 1. B. Using part A, explain why the reciprocal of 5 times 7 is 1/5 times 1/7. Because 5 times 7, it's 35, and times 1/7, which is really just 1 times, or 1/5 times 7, which is 1/35. I wonder if that helps with 31. I don't think it does. Okay, problem 33. What is the product of negation 8 and the negation of 1/8? Well, we know with one of our negation properties is that a negation times a negation is just a double negation, so that will just give us a +1. B. Explain why the reciprocal of negation 8 is negation 1/8, or 1/8. Okay. So I'm assuming that this can be here, and this can be here. Using part A. Yeah. Is that what they're asking for? Using part A, explain why the reciprocal of negation 8 is the negation of 1 over 8. Yeah, so because that just turns into gives us 1. Yeah, this whole expression is just negative. So yeah, I think we explained it right. I don't really know what they want. But let's go back to problem 31. Using part A, explain why the reciprocal of 1/2 is 2. I really think that they're asking for something like this. Like 1 over 1/2. And somehow that equals 2. Well, okay. Let's think about this. I'm gonna rewrite this. So problem A, we have 1/2 times 2. Well, that's really just 1/2 for 2 over 1. And then that's 2 over 2, which gives us 1. That's why we get 1. Yes, also with the property or the definition that they gave us, we get 1. But this is what it's really doing. Now, can we use that for problem B? Explain why the reciprocal of 1/2 I don't think it helps. But I do think this is what they're trying to get at. But I don't know how to work it out mathematically. I don't think I understand what they're asking for. Like, what type of answer do they want? Explain why the reciprocal of 1/2 is 2. What in the world? What do they want? Okay. I think I'm overthinking this. I have to look at that definition. So 1 over x times x equals 1. Explain why the reciprocal of 1/2 is 2. So if we just said 1/2 well, what's the reciprocal of 2? 2 gives us that, and then 2 gives us 1. Well, the reciprocal of 1/2 gives us that result. So the reciprocal of 1/2 is 2. So this reciprocal of 1/2 is this, and that still gives us, doesn't give us 1, gives us 2, right? Yeah, it gives us 2. My brain is breaking right now. It's like, wait, what? Okay, what is going on here? We have our definition. We're saying that the reciprocal of x is 1 over x. And if we take the reciprocal of the reciprocal of x, we get this, we get x. So we can say, and they're saying that the reciprocal of 1 over 2, which is the reciprocal of 2, can get us, okay, so they're asking, they want us to know is, why does the reciprocal of, or the reciprocal of the reciprocal of 2 give us back 2? And for that, I have no idea, without using division or something. Okay, so I know what they're asking for, but I don't know how to work it mathematically. So if we take the reciprocal of 2, we're left with this. and we can what does the reciprocal of the reciprocal of 2 give us? 2. Can't use division because they haven't taught us that yet. Okay. This is 1/2. What do I need here? Because what reciprocal do I need to get this? So what is the reciprocal of 1/2? Well, it's just 2. And I can get this back. Is that what they're asking for? I think that's what they're asking for. So I think it's safe to assume that we've answered that question. And I will just rephrase my answer again. By the multiplicative inverse, the definition that the book gave us, we know that the reciprocal of x is 1/x, and if we multiply them, we can get 1. So I said, okay, if we take 2, we just leave it out for now. Just leave it out. We now need to figure out, okay, if we have this reciprocal here of 2, what can we get? Or what number do we use to get 1? In other words, what is the number that we use to get 1? And the answer is 2. So we know that reciprocal of 1/2 is 2 because we still get 1. That makes no sense in my head, but I think that's what they want. So I think we answered all the problems. So now we have to check. Okay, so let's move on to now the answers for our problems. It's not a lot, actually. Okay, so we're like to assume that every number has a reciprocal, but we can't do this because number 0 is special. We know that 0 times any number is 0. If the number 1/, existed. Oh wait, if the number 1/0 existed, then 1/0 times 0 would have to equal 1. But recall part A, the product of any number and 0 must be 0, so 1/0 cannot exist, therefore 0 cannot have a... Oh wow! Their answer is way more... There's a reason to it. I just said you can't have 0 in the denominator. If the number 1/0 existed, then 1/0 times 0 would have to equal 1. They're using a definition. They're saying that, okay, let's say that you can't have 0 in the denominator. Well, by that definition, this would have to equal 1. But we know that anything multiplied by 0, which you've said right here, you said explicitly that anything multiplied by 0 gives a 0. Well, you're now saying that when we have the reciprocal, there's a special case for it. No, that doesn't work. When you multiply anything by 0, you do not get 1. You get 0. I understand now. Oh boy. Okay, problem 29 tells us that we have to be careful with reciprocals. A number must be non-zero in order to have a reciprocal. The reciprocal of 0 is undefined. Oh, okay, let's now look at some properties of reciprocals. The nicest numbers for multiplication is 1, so it makes sense to first look at 1 over 1. Explain why the reciprocal of 1 is 1. Well, they're saying that, okay, use that definition. Explain, like, how can we get 1? Well, anything multiplied, or not anything. But when we just multiply 1 times 1, we get 1. We don't need to do this, because we know that's really just 1. Okay, so we got that covered. Now, on to the problem that didn't really make a lot of sense to me. So, by the definition, problem A, 30 or problem 31A, by the definition of reciprocal, the product of 1/2 is and 2 is 1. Okay. Problem B, from part A, we see that the number that fills in a blank to solve. Okay, so they're using the same strategy as the previous problem, problem 30. And they're saying that, so see how this right here, they're saying that x is actually 1/2 this time. Right? And we need to figure out what can give us 1. And I know that this is that. But they just ignore that and just say this is 2. 2 can give us 1. So I don't think they set anything equal to x. They just say, hey, this is what we're trying to figure out. And we know that when we multiply by 2, we get 1. So the reciprocal of 1/2 is 2. Okay, they continue by saying, we just showed that the reciprocal of 2 is 2. In the same way, for every non-zero number, we can show that the reciprocal of 1 over x is x. We can write that property as this. I don't think I get this. Like, I have no idea what they're trying to say. Like, I get this definition, but I don't see how I don't see their reasoning. Oh, wait, I think I see what they're doing. I see what they're doing now. So they say that, but that number, by definition, is a reciprocal of 1 over 2. So the reciprocal of 1 over 2 is 2. And I think what they're getting at is, well, we have this blank number equals 1. There's supposed to be like a 1 over x or something. But we don't need to do that. We could just skip that part and just put a 2 there, or an x. But we know by the definition that this is supposed to look like this. But we didn't have to do that, because the reciprocal of 2, or x, or the reciprocal of 1 over x is really just x. Oh my god, yeah, I don't get it. I thought I just had it. I don't get it. but I do get the definition. I get this part because I can explain that algebraically. Oh, what just happened? Okay, we're back online. Yeah, I don't get it. So I'm just gonna move on and then try to understand it off the stream because I don't want to take too much time. So let's move on. Problem 32. Reciprocal of reciprocal, let x be a non-zero number, then 1 over x is non-zero and its reciprocal is x. How do we multiply reciprocals? The next problem shows how. So okay, problem 32. I understand this completely. We multiply both expressions. We're able to move the numbers around and get 1. So the answer is 1. And then B, we show that it's basically just combining the reciprocals. And we see that, well, 1 over 5 times 7 is the same as, or is the reciprocal of 5 times 7. And this basically just says, well, this and this is really just this. And you can do that for multiple products, so x, y, z, or on to infinity. Okay, so I understand that one completely. Like I can tell you that, okay, well, 1, 3, 7, 8, all the way to n. This all combined gives us this. This is what this represents. But when we take the reciprocal of this, we get this. And if we combine that, if we were to multiply this to here, we get 1. I get that. How do we find the reciprocal of a negative number? The next problem shows the way. Negation times negation. Yep, because a double negation property. So that gives us a positive 1. Okay, and I get that. They're just saying that this is the same thing as that. So these are the same. That makes perfect sense because the negation is just telling us that this is a negative number. If we take the reciprocal of this, then we're left with negative 8. Okay, and the new definition, or reciprocal of negation. Okay. Yeah, I think I understand it. Okay, yeah. They're just saying that the reciprocal of negation 8 just gives us this, and we still get 1. So we can assume that, or we just know that these are the same then. Because we've already shown in problem A that we get 1. Okay. Now we can move on to the exercises. What is the reciprocal of negative 1, or the negation of 1? Well, it's really just this. Okay, problem 2. What number is not the reciprocal of any number? 0? What number, wait, hold on. What number is not the reciprocal of any number? Yeah, it would have to be 0 because we get an undefined. And to have a reciprocal number, the product has to equal 1. Okay, what is the product? What is the product of... Okay, so here's a word problem. And to preface this, as a young kid, I've always been horrible at word problems. Always. And it's something I've always struggled with. I just don't understand. My brain just says, yep, I can't do it. But we're gonna get better at it. So let's try to tackle this problem. So 1.63. What is the product of any non-zero number and twice its reciprocal? So we have an x. What is the product of any twice its reciprocal? So if I did this, well, I know that I can do this. That gives me this, and that's the identity function, so we get this. Or identity number for multiplication. So we just get our same result back. So I think that's how you solve it. We get 2. Multiply the negation. Huh? Okay. There's another word problem. Crap. Multiply the negation of a positive number by the reciprocal of that same positive number. Is that what they're asking for? Multiply the negation. Multiply the negation of a positive number by the reciprocal of that same positive number. What is the product? I think we're left with this. So we're left with the negation of 1. Okay. Next problem. We can use just distributive property, so we can do this. It's a lot of numbers, but I think I already see what they're doing. We can combine these, so you see how, so it's multiplication. Like this expression, it's multiplication, so we can move these numbers around. Same as this one, same as this one. We can move these numbers around. But you see how that 1/2 and 2 exist? We combine those, we get 1, so we're really left with 3 times 4. That's 12. Let's do the same thing here. Move those numbers around, we get 2 times 4, that's 8. Let's do the same thing here. 1/4 times 4, that equals 1, so 2 times 3 is 6. We get 26. Okay, now let's check our answers. Okay. That is correct. That is correct. That is, whoa, we got it right. Yes. Okay, good. Somehow we got 4 right. We didn't really do it the same way, but we somehow got it right. We got this one right. So for this problem, they did it like this. They said, take that reciprocal, that x, and then, I mean, this is all just multiplication, right? So we know that we can just combine that, and we're still left with that negation 1. That's 1 times negation 1. So we still get the same answer. It's just that I don't know, it just didn't make sense of the word problem that much. So I wonder if I didn't really get it right. Multiply the negation of a positive number. Multiply the negation of a positive number by the reciprocal. I should have said, yeah, multiply the negation, okay, of a positive number by the reciprocal of that. I could have thought about it like that, but I'll keep note of that. And I'm also gonna go back to problem 31 and really just try to understand. Same with this one. Like I said, I thought I understood it, but I think it would just be important to like watch a video or two on reciprocals and really understand. So that's what I'm gonna do after the stream. So we finished all the exercises. We got mainly all of them right. Just a few questions on this one. Like, did I really get it right? I don't know. Yeah, I think that's all for this stream. So thank you for joining me on another study session. I know it was pretty quick, but it was a pretty short chapter, or a lesson, I should say. And yeah, I had a lot of fun. I learned a lot about reciprocals. and I hope to do another stream tomorrow on division. And then the last lesson will be a summary, I believe. Yeah, because we already did subtraction. That was just utilizing negation towards our, yeah, okay, I get that. So yeah, that was a lot of fun. So see you guys tomorrow. Bye.